Hi everyone, welcome to our video tutorial on relays and their crucial role in control panels. Whether you're an engineer, a technician, or just someone curious to know about how control systems work, this video is for you. By the end of this tutorial, you understand what relays are, how they function, and why they are so important in control panels. Let's dive in. So, a relay is an electrically operated switch. It uses a small electrical signal to control a large electrical load. Think of it as a middleman that allows a low power circuit to control a high power circuit or a high voltage circuit safely and efficiently. So relays, they are made up of several key components. But in this video, maybe we are just concerned about probably two parts, the coil and the contacts. So a relay, it consists of two parts. The first part that we're going to talk about is the coil. The coil look like something as shown on that slide there. And this coil is an electromagnet that gets energized when a small current flows through it. And then the other component of it are the contacts. So the contacts, these are switches that open or close when the coil is energized. So the working principle of a relay is very simple. What happens is that the coil is supplied with a current, and as current flows through the coil, that coil is, and then it acts as a magnet, which will then cause the contacts of a switch to close or open. So for example, that switch that you can see there is open, and if that coil is not energized, then that's the natural state of that coil, and we call that a normally open contact. So the normally open, this is the state of the relay when it is not energized. So if you've got a normally opened relay, if you energize it, that contact will then close, and then current will be able to flow through the contacts 13 and 14 as shown. And when that current is then switched off, the coil will then de-energize, and that contact, it will then open. Back in the days, control systems used to consist of relays, but in this modern day, we use PLCs, DCS to create algorithms to control various equipment. However, relays are still used even today, but mostly as a buffer between the actuator and the PLC in order to control the PLC. So there are various types of relays. There are electromechanical relays. These are the traditional relays without moving parts. They are reliable and widely used. Then there is the solid state relays. They have no moving parts, and they use semiconductor devices to switch currents. Then there are read relays. Then there are time delay relays. These, they have got a timer inbuilt inside them, and we use them for various applications where you switch on a switch, but then you need the equipment maybe to delay starting. So we'll probably cover that in the sections to come. So without relays, many of the devices and systems will not work as efficient as we want. Right, so let's take a look at this relay that is showing on the screen there. So this one, it's a 4-pole control relay with 2 normally opened and 2 normally closed contacts. So you can see the coil with A1 and A2 as the input and the output. So what you simply do with a relay like this, you put a current input through the coil A1, and then A2 is connected to your neutral. This one, it has got two contacts which are normally opened, which means in their natural state, before we energized, we have two contacts which are open. That's the 2NO, and two contacts which are closed. That's the 2NC, right? So if you have an equipment that you want to control using this relay, let's say you want to use this relay as a switch, you can connect your equipment or your component on the NO contacts. 13 is in, 14 is out. So once you connect your equipment there, and then if you allow a current to pass through that coil, the coil, it gets energized and it acts as a magnet, which then causes the contacts between 13 and 14 to close, and then the circuit will be completed, and then current will then be able to flow in that main circuit. So one thing that you should know is that the coil is supplied by its own supply, and usually a DC source, and then the contact 1314 might be an AC source, maybe a bigger source. So in this case, we have two inputs, one input for the coil and one input for the contacts. Okay, so this is a simple schematic. So you can have your load, which is shown there, which is being maybe supplied, maybe we have a power supply that is supplying our load. But then you see that we have an NO contact, which means the load will not start because the circuit is not closed, it's open. Then we have got this coil of the relay, which is also fed by its own power source. So if you are to to feed this coil, it becomes energized and the contact will close, and then current will be able to flow right round, and then the load, whatever it is, it will have some power or it will start working. So this is how a relay works. We are using this relay to switch on or off the load. So you can have a relay with maybe one normally open contact, or it can have one normally closed contact, or it can be a 4-pole as shown at the top right corner, where we've got two normally opened and two normally closed contacts. So in the next video, we're going to talk about the contactor, which works exactly the same way as the relay.